Picture this. You're standing in the middle of a desert, miles away from the nearest city, no cell towers in sight, no Wi-Fi networks to latch onto. And normally, this is where your phone becomes little more than a camera and a clock. But this time is different. You pull out your iPhone, and instead of seeing those familiar, frustrating words, "no signal," you're still connected. You send a message, it goes through. You open a map, it updates. Maybe you even make a call. It feels almost unreal, like the rules of connectivity have quietly changed without anyone announcing it. And in many ways, that's exactly what's happening. For decades, mobile communication has depended on a simple but limiting idea: you need to be near a cell tower. Your phone sends signals to that tower, the tower connects you to the network, and everything works. But step outside that tower's range, and you're cut off. It doesn't matter how advanced your device is, without infrastructure nearby, you're disconnected. This has been one of the most persistent limitations of modern technology. We've built incredibly powerful smartphones, capable of doing almost anything, yet they still rely on a network that has physical boundaries. That's where the idea of satellite connectivity changes everything. Instead of relying solely on towers planted across your phone could connect directly to satellites orbiting above it. These satellites don't care if you're in a crowded city or a remote mountain range. As long as you have a clear view of the sky, there's a path to communication. It's a fundamentally different approach, one that replaces the idea of coverage zones with something much closer to true global reach. Now imagine combining that concept with the ecosystem of a device like the iPhone. Apple has always focused on tightly integrating hardware and software, creating a seamless experience that feels almost invisible to the user. If satellite connectivity becomes part of that system, it wouldn't feel like a separate feature or a backup mode. It would simply be another layer of connectivity working quietly in the background. You wouldn't have to think about whether you're connected to a tower or a satellite. Your phone would handle that automatically. On the other side of this equation is a rapidly growing network of satellites designed to provide internet coverage across the globe. Unlike traditional satellites that sit far away and introduce noticeable delays, these newer satellites orbit much closer to Earth. That proximity reduces latency and makes real-time communication more practical. Over time, thousands of these satellites have been launched, forming a kind of mesh in the sky, constantly moving, constantly providing coverage. The idea of connecting smartphones directly to that network has long been considered a technical challenge. Phones are small, power-limited devices, not designed to transmit signals over such vast distances. But advancements in antenna design, signal processing, and chip efficiency are beginning to close that gap. What once required specialized equipment is gradually becoming possible with devices people already carry in their pockets. At first, the implementation of this technology is likely to be modest. Think simple text messages, emergency communication, basic location sharing. These are low-bandwidth tasks, easier to handle with the limited capacity available. And even that is a huge step forward. Being able to send a message from anywhere, especially in an emergency, can be the difference between safety and danger. It transforms a smartphone into a lifeline in situations where it would otherwise be useless. Over time, as the satellite network expands and becomes more capable, the range of possible features grows. Data speeds improve, latency decreases, and more complex applications become feasible. It's not hard to imagine a future where streaming, video calls, and full internet browsing are possible even in the most remote locations. That future might not arrive overnight, but the trajectory is clear. One of the most interesting aspects of this shift is how it changes our expectations. Right now, we accept that connectivity is inconsistent. We know there are places where our phones won't work, and we plan accordingly. We download content in advance, we inform people when we'll be out of reach, and we carry backup devices if communication is critical. But if satellite connectivity becomes widespread and seamless, those habits start to fade. The expectation becomes simple: your phone works everywhere. That kind of reliability has far-reaching implications. For travelers, it means never worrying about losing contact while exploring unfamiliar places. For emergency responders, it means maintaining communication even when infrastructure is damaged or overloaded. For people living in remote areas, it means access to services and information that were previously out of reach. It narrows the gap between connected and unconnected parts of the world. There's also an economic dimension to consider. Building traditional network infrastructure is expensive and time-consuming. It requires land, permits, maintenance, and constant upgrades. In many regions, especially those with challenging geography or low population density, it's simply not viable. Satellite networks, while complex in their own way, offer a different kind of scalability. Once the satellites are in orbit, they can cover vast areas without the need for physical installations on the ground. This doesn't mean that cell towers will disappear. On the contrary, they will remain the primary method of connectivity in densely populated areas where they are most efficient. Satellite connectivity acts as a complement, filling in the gaps rather than replacing the existing system. It creates a hybrid network where devices can switch between different types of connections, depending on what's available and most effective at any given moment. That seamless switching is one of the key challenges. It requires sophisticated software and coordination between different network systems. Your phone needs to know when to stay on a cellular connection, when to switch to satellite, and how to do so without interrupting whatever you're doing. This is where tight integration between hardware and software becomes crucial. The smoother the transition, the more natural the experience feels. Another challenge is managing the limited bandwidth of satellite connections. Unlike cell towers, which can handle large numbers of users in a concentrated area, satellites have to distribute their capacity across wide regions. This means prioritization becomes important. Emergency communications, for example, might take precedence over less critical data. Systems need to be designed to ensure that essential services remain reliable even as demand grows. Battery life is another factor that can't be ignored. Communicating with satellites requires more power than connecting to nearby towers. If not managed carefully, this could lead to faster battery drain. Advances in chip efficiency and intelligent power management will play a big role in making satellite connectivity practical for everyday use. The goal is to provide the benefit without significantly impacting the user experience. There's also the question of regulation. Telecommunications is governed by a complex web of rules that vary from country to country. Introducing satellite-based communication into consumer devices requires navigating those regulations, securing approvals, and coordinating with existing network operators. It's not just a technical rollout, it's a global effort that involves multiple stakeholders. Despite these challenges, the direction is clear. The technology is advancing, the infrastructure is expanding, and the demand is growing. People want reliable connectivity, and they want it everywhere. The idea of being cut off, even temporarily, feels increasingly outdated in a world that is otherwise so interconnected. At a deeper level, this shift represents a change in how we think about communication itself. For most of human history, communication was limited by distance. Messages took time to travel, sometimes days, weeks, or longer. The invention of telecommunication technologies gradually shrank that distance, making it possible to communicate instantly across vast spaces. Satellite connectivity continues that trend, pushing it toward a kind of ubiquity where location becomes almost irrelevant. There's something powerful about that idea. It suggests a world where information flows freely, where people can stay connected regardless of where they are. It opens up possibilities for education, healthcare, business, and social interaction in ways that are hard to fully predict. At the same time, it raises questions about how constant connectivity affects our lives. When there's no escape from the network, do we lose something valuable? Or do we simply adapt, finding new ways to balance connection and disconnection? From a technological perspective, the integration of satellite connectivity into smartphones is a complex puzzle with many pieces. It involves advancements in hardware, software, network design, and even user interface. Each piece has to fit together in a way that feels seamless and intuitive. The end goal is not to impress users with complexity, but to hide that complexity entirely, delivering a simple and reliable experience. As this technology becomes more common, it could also influence the design of future devices. Antennas, chips, and power systems might evolve to better support satellite communication. New features could emerge, built around the assumption of constant connectivity. Developers might create applications that take advantage of global coverage, offering services that were previously impractical. There's also a competitive aspect to consider. In the world of consumer technology, new capabilities quickly become expectations. If one device offers a significant advantage, others follow. Satellite connectivity could become one of those defining features, something that distinguishes one generation of devices from the next. It could drive innovation, pushing companies to improve performance, efficiency, and integration. At the same time, the success of this technology depends on user trust. People need to feel confident that their devices will work when they need them most. Reliability, security, and privacy all play a role in building that trust. Satellite communication introduces new considerations in each of these areas, and addressing them effectively is essential. Looking ahead, it's not difficult to imagine a future where the phrase, "no signal," feels like a relic from another era. Just as we've moved beyond dial-up internet and limited storage, we could move beyond the idea that connectivity has boundaries. It won't happen all at once, and there will be challenges along the way, but the trajectory points toward a more connected world. And when that future arrives, it might not feel as dramatic as we expect. There won't necessarily be a single moment when everything changes. Instead, it will be a gradual shift, a series of improvements that add up over time. One day, you'll notice that you haven't seen no signal in a while. Your phone just works, wherever you are. And that will be the real transformation, not a flashy announcement, but a quiet change in what we consider normal. In the end, this is about more than just technology. It's about access, reliability, and the way we interact with the world around us. It's about removing barriers that have long been accepted as inevitable. The idea that your phone can stay connected almost anywhere is not just convenient, it's empowering. It changes what's possible, both in everyday life and in extraordinary situations. So the next time you venture into a place where you'd normally expect to lose signal, consider that the experience might soon be different. The sky above you, filled with satellites moving silently in orbit, could become part of your everyday connection. And the simple act of sending a message or making a call, no matter where you are, could become something you no longer think twice about.